Hello, I'm Christine Träger-Chatterjee, and in this presentation, I would like to give you a brief overview on the Satellite Application Facility on Climate Monitoring, also known as CMSAF. The CMSAF is EUMETSAT Center of Excellence for the development and the provision of climate data records, and I will explain later in this presentation what climate data records are. As all SAFs, also the CMSAF is a consortium of different entities such as national meteorological services and research institutions of EUMETSAT member states. The CMSAF is led by the German National Meteorological Service, Deutscher Wetterdienst. Why is climate monitoring important? It is scientific consensus that the Earth's climate is rapidly changing at the moment and that this has implications on our everyday lives. So it is crucial for society to adapt to these changes. And to be able to adapt and to mitigate the impacts of climate change, we need to know what will happen, and this is predicted using climate models. To be able to develop climate models, we need to understand the physical processes. And for this, we need observations. Also for the validation of climate models, observation data are needed. Furthermore, observation data are used to monitor and analyze the current climate and its evolution in recent decades. Climate monitoring data need to fulfill certain requirements. The time series needs to be sufficiently long. For climate monitoring, the time series should cover several decades of observations, ideally 30 years or more. All data in the time series need to be homogeneous. The instruments that are used over the time series need to be carefully calibrated and intercalibrated to ensure that measurements at different times and different locations are comparable. Two issues need to be considered in this context. First, the sensitivity of the measuring instrument changes over time. The sensitivity of a satellite sensor in space usually decreases over time. And second, when collecting observations over several decades, this usually means that one has to deal with changing instruments. So instruments are replaced by new ones over such long time scales. And different instruments always behave slightly different. And this needs to be accounted for when creating climate data records. To ensure that trends are variations in the data record and are due to actual changes in the environment and not due to artificially introduced changes by the sensor. And last, but not least, the data needs to be quality controlled to ensure that metadata are complete and that the data meet the defined accuracy requirements. Data from meteorological satellites are acquired with high temporal frequency. In other words, every few minutes from geostationary satellites, for example. And as they come in, retrieval algorithms are applied to provide geophysical information of the presence in the very recent past. The result of this is then called data for operational climate monitoring or environmental data records. However, these satellite data are archived over decades. So we have them from the EUMETSAT archives them from the very beginning of its satellite measurements. And this enables us to provide long-term climate data records covering several decades. However, several decades of satellite data mean that we need to work with different instruments as satellites are replaced by new ones, as this is indicated here on the right-hand side of the slides. So this means new instruments are being developed, and moreover, also the sensitivity of individual instruments changes over time. And this is shown here. What you see here is the brightness temperature difference between the difference in the brightness temperature between an actually measured brightness temperature of a satellite sensor and the calibration target. Calibration changes that are introduced over time to cope with the changing sensitivity of the sensor can be identified also, and also the changes of instruments when a satellite has been replaced. So here, this is the changes that are introduced due to calibration changes. And sorry, go back one step. And this here would be the changes of an actual instrument. So a new satellite is placed in orbit. This all needs to be accounted for when when we need to prepare or when we prepare the archived satellite data for climate data records. So a careful and intercalibration of the satellite data is necessary, and the result of that is called a fundamental climate data record, or FCDR. In addition to the changes in the satellite measurement itself, so the change of sensor sensitivity and replacement of instruments, also the retrieval algorithms applied evolve over time. So new and better procedures are developed. For environmental data records, always the newest algorithms are applied. So if we'd only use the operational climate monitoring data, we would deal with the geophysical information that is retrieved using slightly different algorithms. For the creation of climate data records, however, one and the same, we call it a stable algorithm, is applied to the homogeneous FCDR, the fundamental climate data record. And the result is a data record of climate quality, a CDR, which can be used for long-term climate analysis, such as variability and trend analysis. A relatively new scheme are the so-called interim climate data records, or ICDRs. They are produced to fill the gap between the end of a climate data record and the present time. To produce an ICDR, the same algorithm as for the creation of a CDR is used and applied to the recent satellite data, which have not undergone careful recalibration and intercalibration procedures. However, it is considered that ICDRs are closer to climate quality than operational data records are. The CMSAF now provides data on the climate data records on the energy and water cycle. So they provide several parameters on thermal radiation, solar radiation. They provide the surface albedo, cloud coverage, information on cloud properties, and over ice-free ocean. They also provide a climate data record for near-surface wind speed, precipitation, evaporation, freshwater flux, and latent heat flux. And if you would like to know more about the CMSAF product portfolio, then please visit their webpage at www.cmsaf.eu.